Today we are going to learn about solving systems of equations by elimination. We learned to solve systems of equations by graphing. The solution was where the two graphs crossed. Using the elimination method, we will come up with a coordinate point, which would be where the two would cross if it were to be graphed. The problem we are going to look at today is y minus x equals 1 and y plus x equals negative 3. To do the elimination method, you're trying to find a way to get something to cancel. This problem is set up really nice for us because this negative x and this positive x will cancel. So what I'm going to do is I'm going to add up each column. You can only add y's with y's, x's with x's, and constants with constants. So in this case, I have a 1y and a 1y. So 1y plus 1y is 2y. Then I have a negative 1x and a positive 1x. These cancel. This is where the elimination method comes into play. Those two eliminate. Then I bring down my equal sign, and then I have 1 minus 3. 1 minus 3 is negative 2. Now I have a simple one-step equation. I'm going to go ahead and solve this for y by dividing by 2. So I get my answer is y equals negative 1. Just having y will not give me a coordinate point. I now need to take this y equals 1 and substitute it into one of my original equations. I'm going to use the first one. I'm going to take negative 1 for y. I'm going to put parentheses to know that I substituted it in. Minus x equals 1. Now I'm going to solve for x. So if I have a negative 1, I'm going to add 1 to both sides. That cancels, giving me negative x equals 2. I need to get a positive x, so I'm going to divide by a negative 1. So I get x equals negative 2. Therefore, my solution should be a negative 2, negative 1 coordinate. On the next part, I'm going to show you how to check to see if that's correct. Okay, I'm going to check to see if my answer, negative 2, negative 1, is the solution to the system of equations. In order to check your solution, you should take the number for x and substitute it in for x, and the number for y and substitute it in for y. So I'm going to take negative 1, we have a minus my x of negative 2, and we're going to see if that equals 1. A negative negative becomes positive, so I have a negative 1 plus 2 equals 1. Negative 1 plus 2 is indeed 1. So the first one checks. Now we need to do the same thing into the second equation. So I'm going to plug in a negative 1 for y plus a negative 2 for x, and we're going to see if that gives us 3. So if I do this, I end up getting negative 1 plus negative 2. That gives me a negative 3 equals 3. So that's not quite right. And I realize that I made this mistake up here, that this is supposed to be a negative 3. If you go back to the original equation, this should be a negative 3 here. So this is actually the answer. So again, your answer is negative 2, negative 1, written as a coordinate.